part 2 to the 12.5 video, so make sure that you watch part 1 first, and then you can watch this part. And then after this, you'll do an exit ticket in Polaris that go over the questions instead of having questions in here. That way you can actually put in numbers rather than just answer multiple choice questions. So this example says, and we're working again with independent and dependent events and comparing them and using the conditional probability rule. So you select 2 cards from a standard deck of 52 cards. What is the probability that the first card is not a heart and the second card is a heart if you replace the first card before selecting the second, and then do not replace the first card? So the big thing about this one, there's a lot of words here, but the first one is that you're taking a card and you're going to replace it. So that means the second time you pick a card, there are still 52 cards in the deck, including the one that you first selected. And therefore, the second time you pick a card, it's not going to be influenced by what you picked the first time. But if you don't replace it, then what you pick the second time is going to depend on or be affected from what you picked the first time. So there are 2 different things that we'll do here. The first one, part A will be a independent events, and part B will be dependent. So for part A, it says, what is the probability the first card is not a heart? So we're going to take not a heart and then multiply it by heart. So not a heart, well, 3/4 of the cards are not hearts because a fourth for pursuit. And then times the probability that it is a heart, that would be 1/4. And then 3/4 times 1/4 is 3/16. So that's for independent events, so independent. And then for dependent events, if you don't replace it, well, the first time is still 3/4, but the second time, you now only have 51 cards, and then if you didn't pick a heart, that means there are still 13 hearts. Okay, now you gotta be careful because if they're doing like 2 of the same things, then you would reduce the numerator to 12. But here, since we didn't pick what we're trying to pick the second time, you don't need to. And then you can do a little bit of mental math before you start. 3 and 51 are actually go into each other with 17. So 51 is not prime. And then that would be 13 over 4 times 17 is 68. So that's about 0.191 or 19.1%. Right. So the same thing with this second question, part B. Find the probability that of drawing the given cards from the standard deck of 52 cards with replacement and without replacement. So a spade, then a club. So there are 1/4 of them with replacement. 1/4 are spades and 1/4 are club. So that makes 1/16. If you don't replace it, then you've got the same 1/4, but then when you pick a club, there's 13 clubs, but only 51 cards left. So that's going to give you 13 over 204, which is 0.064. Okay, so that's questions like that. You'll have a whole question in Edulastic that's like cards and with replacement and without replacement. Okay, and these questions are good. I probably will need more room, but we'll work with it. Okay, so this says, using observations made of drivers arriving at a certain high school, a study reports that 69% of adults wearing seatbelts while driving, and then a high school student also in the car wears a seatbelt 66% of the time that the adults are wearing the seatbelt, and then 26% of the time when the adult does not wear the seatbelt, which would be 31% of the time. What is the probability that a high school student in the study wears a seatbelt, including both if the parent wears the seatbelt and if the parent doesn't wear a seatbelt? So a good strategy for answering a question like this is to make a big old Venn diagram. It's not Venn diagram, but a tree diagram. So we're going to make a double tree diagram. So we're going to start over here, and then we're going to have, first of all, it's going to be with the parent, because the high school or the student wearing the seatbelt depends on the parent, the probability of the parent wearing the seatbelt. So the probability that the adult wears a seatbelt is 0.69. So we're going to say adult seatbelt. Just making sure I don't do any abbreviations that we don't want. Okay, so that would be 0.69. And then 0.31 would be adult, and I'm just going to say adult check, adult not check, so not wearing a seatbelt. That sounds easier. And then for the student, they're wearing a seatbelt 60% of the time when the adults are wearing a seatbelt, so that'd be 0.66. And then we'll say student check. And then how about if the adult is wearing a seatbelt, but the student is not? So that would be coming from here, and that would be just 100% minus 66%, which is 0.34%. So this is the student does not wear a seatbelt, given that the adult does. And then here, it says that 26% of the time when the adult does not wear a seatbelt. So if the adult doesn't wear a seatbelt, there's a 0.26% chance, or 0.26 likelihood, that the student is going to wear it. And then if the adult isn't wearing it, then there's a 74% chance that the student also isn't going to be wearing theirs. So hopefully we're all wearing our seatbelts when we're in the car, even if you're just driving to school, something can happen. Okay, so then what is the probability that a high school student in the study wears a seatbelt? So that would be this circle, or this outcome, and that would be this outcome. But notice that there are 4 different outcomes here. There's the adult wearing a seatbelt and the student does, adult does and student doesn't, adult doesn't and student does, adult doesn't and student doesn't. So there are 4 different outcomes that we can find the probability of. And to do that, we would use the multiplication principle. So adult does and student does, 0.69 times 0.66. So 0.69 times 0.66 would give us 0.4554. So this is yes adult, yes student. So this is one of the probabilities that we want. And then for yes adult and no student, you don't need to find this, but I am just going to, for the purpose of showing you something at the end here. So if we did 0.69 times 0.34, we get 0.2346. So this is yes adult, no student. And then no adult, yes student would be 0.31 times 0.26, and that gives us 0.0806. So it's a really small chance that if the adult's not wearing the seatbelt, then the student probably is not either. So no adult, but yes student. So small chance that the student is going to be wearing it. And then no adult, no student is 0.31 times 0.74, which gives us 0.2294. So this is no adult, no student. So once again, these are the 2 numbers then that we would add up to get our answer of, you added these 2 percentages together, you would get 53.6%. But also, if you take all 4 of these outcomes and add up the percentages, guess what you get? 100%, or 1 if you just look at the decimals. So all of these should add up to 100%. Okay, these percentages won't add up to 100, just like the individual ones, like these 2, then those 2, then those 2 will add up to 100%. So anyways, so there's a couple questions on your 2 questions at the end of the Elastic like this. The very one at the end is conditional probability though, so you have to think a little bit harder on that last one. But let me show you one more example here of this type of question. So high school basketball team leads halftime in 60% of the games in a season. So so at halftime, they're saying that the basketball team is leading 60% of the time. Okay, so we'll start there. So leads, and then we'll say no leads. So leads would be 0.6. Not leading would be 0.4 at halftime. So we're talking about halftime. And then the team wins 80% of the time when they have the halftime lead. So here, this would be 0.8 win. And then if they are leading, then we can infer that there's only 0.2% chance that they lost. And then if they don't lead, then they only have a 10% chance of winning. You need to work on their not leading strategy, and then or their comeback strategies, and then 0.9 they would have as a loss. So then what's the probability that the team wins a particular game during the season? So that would be this outcome and this outcome. So to find this outcome, we would take 0.6 times 0.8. And that would give us 0.48. And then that would be if they're leading, then they win. In this one, we would do 0.4 times 0.1, which is 0.04. That would be not leading, but winning. And if you add those two up, you get 0.52 or 52%. So the probability that the team wins is 52%. You can find the other probabilities for other reasons, but we don't need to here. So that's all for this one. So once you're done with this, make sure that you go into Polaris and do the exit ticket. Have a great day.